This is a walkthrough of Problem 2 on Exam 2 of Module 2 from the book Problem Solving Guide for Mechanics and Thermodynamics. Problem 2, an arrow is shot at some initial velocity. After 4 seconds of flight, the arrow has a horizontal displacement of 60 meters and a vertical displacement of 20 meters. How fast is it traveling at 4 seconds? Give your answer in meters per second to 3 significant digits. What was the angle above the horizontal at which the arrow was shot? Give your answer to 3 significant digits. Let's draw a diagram. There's the flight of the arrow. Now let's think. Let's try not to use equations. It's a good problem for those who don't mind thinking. Let's start with the horizontal direction because that's always the easiest direction. Pretty boring. Speed doesn't change. The arrow travels 60 meters in 4 seconds. The average speed in the horizontal direction is 15 meters per second. Since the speed in the horizontal direction never changes, the speed in the beginning in the x direction is 15 meters per second. The speed in the x direction at 4 seconds is 15 meters per second. The average speed over the whole flight horizontally is 15 meters per second. So, check that off our list. Now we got to do the vertical direction. This is harder because the speed changes. The arrow travels 20 meters upwards in 4 seconds. If it goes 20 meters in 4 seconds, the average vertical speed is 5 meters per second upward. That's changing. We know that the vertical component of the velocity at 4 seconds is 40 meters per second less than the initial vertical component because gravity took away 10 meters per second 4 times. If we shot it up at 60 meters per second, it would be going 20 meters per second up after 4 seconds. If we shoot it up at 10 meters per second, it's going down with 30 meters per second after 4 seconds. Okay, now we can think of it like an algebra problem. 2 equations and 2 unknowns. Remember problems like these? What 2 numbers are different by 40 and have an average of plus 5? We know they're different by 40 because gravity took away 40. And we know they have an average of plus 5 because it went 20 meters in 4 seconds. So knock yourself out. Do some math. Let's do some physics. Y is 1/2 a sub y t squared plus v initial y t. The only thing we don't know here is v initial y. Y is plus 20 meters. It's given. T is 4 seconds. Acceleration minus 10 meters per second every second. We're done. We get v sub y. 4 squared is 16, times 1/2 is 8, times 10 is 80, so we have 20 equals minus 80 plus v initial y times 4, put the 80 on the other side, that's 100, divided by 4, that's 25. So v initial y is 25 meters per second. 4 seconds later, it's going 15 meters per second downward. We have to subtract 40 from 25. So minus 15 and plus 25, those are the 2 numbers that have an average of plus 5 and a difference of 40. Let's calculate the average. You add them up, plus 25 minus 15, that's plus 10. Plus 10 divided by 2 is 5. The average is 5, difference is 40, it all works. We have the components of the velocity at 4 seconds, we can get the speed. V is the square root of v sub x squared plus v sub y squared. V sub x is plus 15, v sub y is minus 15. There they are at 4 seconds, and we can calculate the speed, which is 21.2 meters per second. Part B asks for the angle above the horizontal at which it was shot. We have to go back to the beginning. So we know the components of the initial velocity. V sub x is 15, of course, doesn't change, and v sub y initially is plus 25. So we can put those on the diagram, and we have to get the angle at which it was shot, and we can use tangent. Tangent is opposite over adjacent. The opposite side is 25, the adjacent side is 15, that's 5/3. The arctangent of 5/3 is 59.0 degrees. So it was shot 59.0 degrees above the horizontal. That's problem 2. I'm not going to insult you by asking you to calculate the speed of the arrow. That speed. There's the angle.